Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
So yeah, demand circuit and that flood reduction as well.
Yeah.
You remember flood reduction, right?
Yeah.
So demand circuit flood reduction is done. I think you went again back to your home.
No sir.
Then
I almost took my client.
you took
आज भी सर आज भी जाना है
कहाँ पे?
मेरी बस डॉट कॉम मेरे क्लाइंट है सर
What type of client?
सर मैं वहाँ पे काम मतलब उनका जो सिस्टम है वो मैनेज नहीं करता हूँ
Oh, okay. Fine. So we are going to perform now database filtering. Fine. So let me do one thing. Let me have the console of R10 first of all here, and on R10 what will I do? I will shut down this link which is going towards R2, so that R10 will be having only one connection which will be towards R11 only. So serial 1 by 0, just shut it down. Once you will shut down it, then you will see that it will lost neighborship with R2 now, right? So IP OSPF neighborship, you will see that it is having now neighborship with R11 only. So whatever will come here in its on routing table, it will come via R11. As you can see that everything, I mean all prefixes are coming from R11. See, it's not it. Now in OSPF we are having the same feature as RIP, like we were having passive interface over there. Do you remember the uses of passive interface in RIP? That after configuring any interface as passive interface in RIP, then it was not transmitting updates out from passive interfaces, but still it could receive them. Do you remember the uses of passive interface in RIP, right? In same manner, here also we are having one option same as passive interface in RIP, which is known as database filtering. Let's say that what I want, that R11 must not send anything. R11 must not provide anything to R10. Are you trying to get my point? R11 must not send any information towards R10, but R11 must receive information from R10. R10 must give its all information to R11. So what I mean to say, that R11 must not send any LSA out from S1 by 0, but it must keep on to receive them. So it will be same as passive interface in RIP. So for that purpose here we can configure database filtering, right? Remember that database filtering can be configured in outbound direction only, and one more thing, that database filtering can be configured for all types of LSAs. You cannot specify your LSA type actually, that I want to filter only these types of LSAs only. You cannot define that. So now let's do one thing. Let's move back again on R11, and on R11 S1 by 0 IP OSPF database filter. See, here only we can specify all types of LSS. That's why there is only one keyword, which is all, and then after all you can say only and only out. You see, it means that you can configure it in outbound direction only, and then that's it. That's the only command that can be configured on any interface where OSPF is enabled or OSPF is having neighbor. So if of course R11 was having neighborship with R10 onto this interface, and this time it is not gonna to break neighborship. See, in OSPF if you define any interface as passive interface, you know very well what will happen. It will lost neighborship. It will break neighborship if you configure any interface as passive interface, you understand? But this time with using database filter, you will see that it will keep its neighborship up, and also it will keep on to receive updates coming from its neighbor, but it will never transmit any LSA information out from this interface. You understand? So this time you can see that neighborship went down, but again it have came up. show IP OSPF neighbor. See, it's having neighborship with R10. Then you can move on R10 and show IP OSPF neighbor. See, check show IP route. Still it is having. If still it is having routes available in its routing table, do one thing, say clear IP OSPF process. Just clear its process. Once you will clear its process, then you will see that it will not be having any route available inside its own routing table. Not only route, even you will not find anything inside its database table as well. Show IP OSPF database. See, is it having any LSA available inside its own database table now? Tell me. So it does not have any other LSA now in its database table. You know why? Because the link going towards R2, I have already shut it down. It was having neighborship with R11 only. At the end of R11, I configured database filtering now, so that R11 is not sending any type of LSA in the direction of R10. That is why R10 is not receiving any type of LSA coming from R11. So I hope that you people have understood this concept of database filtering in OSPF.
And what will happen if we no shut down this R10 to R2 link?
If you no shut it, then definitely this R10 will start to receive these LSAs coming from R2.
R2, but it will come as
Inter-area, of course,
yeah,
but they will come. I hope that you people have understood it now completely, right?
Yes.
So in this way, you can configure database filtering. You can see that R10 is not receiving any type of LSA now. So if you are required to configure your OSPF in that manner so that your router should not be able to transmit any type of LSA towards its neighbor, then definitely you will configure database filtering. If you do not want to let your router to transmit any type of LSA towards the neighbor, database filtering is the only available option that you can configure over there. Fine. Excuse me. So have you understood it now? And now the thing is, like, if you move back again on R11, you will still see the loopback of R10 coming here. Show IP route 10.10.10.10 coming from R10 itself. See, 110.1.1.10, and this IP address is configured at the end of R10. So still it is receiving this route coming from R10, but it is not giving any routes information towards R10. Even if you check its database table, you will see router LSA coming from R10. So still it is receiving LSAs from its neighbor, but it is not giving any LSA information toward its neighbor. Piyush, this is called database filtering in OSPF. Now the next thing is that how to generate default route in OSPF. How to generate default route in OSPF. And that's very simple, as you know very well. It's very simple to generate a default route in OSPF. And there is only one command available in OSPF to generate your default route. Go to router OSPF 1 and then say default information originate. Do you remember? But if you are configuring this command, it means that this router must have a default route available inside its local routing table as well. If you are configuring this command here in OSPF to generate a default route, then in that case it must have a default route available inside its own routing table as well. That is why if you check its database table, so IP OSPF database, you will not see any type of LSA for this default route, because if you are generating default route by using command default information originate, remember that your default route will always go in the form of type 5 LSA as an external route. But this time there is no type 5 LSA available for default route. Is there? You know why? Because this router does not have any default route available inside its own routing table. Have you understood it? And one more thing, you cannot redistribute a default route into OSPF database. Let's say that you are having a static default route, or you were learning a default route in within ESCRP, and then you decided to redistribute that ESCRP or that static default route into OSPF. Remember, you cannot redistribute any default route into OSPF. I'm removing this command do show run abstraction router OSPF. Understood? Fine. Let's say it is having a static default route now, IP route. I can put it towards. Now it is having a static default route available inside its own routing table. Now do one thing, router OSPF, say redistribute. And if I say do show IP OSPF, you must have a type 5 LSA available for default route. Is there? You must get the default route on R9 as well. You will not get that on R10. You know why? Because you configure database filtering. But at least you must get the default route available here. Gateway of last resort is not there. It means default route have not been redistributed into OSPF. So we have proved it that you cannot redistribute any default route into OSPF. So there is only one option. There is only one way to generate a default route into OSPF, which is with using command default information originate. So I hope that you people have understood the concept behind it, right? So now the thing is, for an example, let's move back again on R11 and just remove that command from here, redistribute static subnets, and then let me show you do show IP route static. So this time it is having a static default route available inside its own routing table. Then you can also do one thing here within router mode default information originate. Right? This time I have configured the same command, but this time you will see that there will be a type 5 LSA available inside its own database table. Do show IP OSPF database. See, it's not it. So it has been generated by R11 itself, and now you can find this LSA available on R9, R1, R2, R3, R4, R5, R6, everywhere in the network in this domain. It's not it, and you will get it. I mean, of course, this default route will be available in the routing table of R9 as well. You can check it now. You see default, see gateway of last resort is what? R11. Hey, 119.1.1.11 is the IP address of R11, right? So of course it is receiving this default route coming from R11. So you see that it is having this default route, and this default route is coming as E2, external type 2. If you want to change its metric type, then it is also very simple in OSPF to do these type of changes, like after configuring default information originate command, define your metric type and all. Metric type 1 by default. For default route, your metric is 1, seed metric is 1. I hope that I should show you that default metric is what? I mean seed metric is 1. Do show IP OSPF database, and then it was external, and then it was for 0000. So you can say now metric type is 1, and then you can also change its metric, which is, let's say, 1. And then after, you are also having this always keyword, and I hope that you people also understand the uses of always keyword. Like for an example, if you do not have default route available here in the routing table of this R11, and still if you want to originate a default route into OSPF, then you can use this always keyword. If you are using this always keyword here along with this default information originate command, then it will not be required, it will not be mandatory for this router to have at least one default route available inside its own routing table. So this router will start to originate default route even in the absence of default route in its own routing table as well, right? So in case if you do not have a default route, let's say for an example, in between ISP and you, the BGP is running, so of course you will be receiving all prefixes coming through BGP only, and then after you are running OSPF, and it is not possible to redistribute BGP into OSPF. Let's say through BGP you were learning like more than 1,000 of prefixes, right? So now definitely it is not possible to redistribute this BGP back into OSPF. Now how will it be possible for all those users in OSPF domain to reach all those external prefixes? In that case, you can originate a default route into OSPF, but in that case, on that router you do not have any default route available, right? So in that case, you will be required to use this always keyword. I think I should show you with using pin ISP customer edge router, BGP is running, you have learned everything through BGP. Then here you are having some routers, R1, R2, these all routers are interconnected here, and OSPF is running. Now OSPF is running on R1 and R2 and in between customer edge routers, right? So problem is now you cannot redistribute BGP into OSPF back. So how will it be possible for R1 and R2 to receive all those prefixes, to reach them? In that case, on CE router itself, inside OSPF, you can originate a default route, so that R1 and R2 will start to receive default route coming from its neighbor customer edge. So I hope that you people have understood the uses of this always keyword now, because this time CE will not be having any default route towards towards the ISP, not only towards ISP, towards anyone, right? So, and still you are required to inject a default route into the database of OSPF. So without having a default route available in the routing table of router, if you want to inject a default route in the database of OSPF, then you have to use this always keyword. So I hope that you people have understood it now. Tell me. And then after, you are also having an option of route map as well. Let me show you route map for conditional, reliable, conditional default routing. Do you remember we performed it in RIP, reliable, conditional, default routing? So in a route map, same as RIP, you can configure those conditions. Do you remember those conditions that we configured in RIP before generating? Yeah, of course, with using IPSLA, and then we configure track object, and then we configured a static route, and then that static route was available in your router's routing table till your track object was up. If track object was going down, in that case that static route was also removed from your router's routing table, and your router was generating a default route till that static route was available. You can match that static prefix. Do you remember that we performed the same thing in RIP as well? So you people can perform the same thing here in OSPF as well, because here also you are having the option of route map, and this route map was not available in case of EIGRP. Do you remember? During default route, in EIGRP, when we configure default route, when we inject a default route in EIGRP, there is no option available of route map. You cannot put any condition, you cannot put any reliable conditional default routing in EIGRP. That's not possible. But in RIP as well as in OSPF, these things are possible. Tell me. If you are having any problem, please let me. Fine. Let's move back again on R11. On it S1/0, I configure the command IPOSPF database, filter all out, remove it. Now switch to IP route. Done. Fine. Then after it, let's go to, have I taught you the uses of MTU here? Like if MTU is mismatched, then you have to use IPOS to MTU ignore command.
Yeah.
Have I taught you?
Yes.
Fine. Apart from that, you can also configure these things. Like, let me show you. Right now, show IPOSPF neighbor. See, it is showing you neighbor ID is what? It's router ID. So by looking at router ID, we can see that okay, 9 is connected with the R11 and 10 is also connected with. But you can also perform some name lookup for these things, like with using these commands like IP host, and then you can give its name like R. You understand? R9 for 9.9.9, and then IP host R10 for 10.10.10, and then IPOSPF name lookup. That's it. IPOSPF name lookup. And now if you configure these things, see, show IPOSPF neighbor. It's not going to show you the router IDs of your neighbor devices. It will show you simply their names, R9 and R10. Understood?
On the IPMP, we should enter in the
In
line
the
which
first-
has low MPA.
Exactly. Show IP OSPF database. See, now in the database table also it will show you under router, let's say, advertising router ID R10 and R9 itself. So it will be better for you for understanding purpose. It will be better for understanding purpose. So these are the advantages of configuring these things. Do show it was very simple. To configure these things, you are not required to move even in router mode itself. Globally, you can configure these things. Apart from it, we are also having some other things too available in OSPF. Some features cannot be configured over here. Like I think I have already told you about TTL in virtual link, as well as cryptographic authentication.
Yeah.
Like 15.3 and onwards, right? Like if you are having 50, even it is also supported in 15.2 as well, but there are multiple types of iOS versions available on Cisco devices. So on some iOS 15.2 it will also be available. This cryptographic authentication will be available. The most important difference in between cryptographic authentication and normal authentication in OSPF is that in cryptographic authentication you can use keychains. And if you can use keychains in cryptographic authentications, it means that you can configure rotational keys. I hope that you understand the meaning by rotational keys. Yes, not in ESERP, even you can also configure rotational keys in RIP as well. But in RIP, because in RIP also, it will be required to configure keychain for authentication. Fine. So I hope that you people have understood all these things now. Fine. After going through all these things, let's talk about global timers as well. Global timers. Router OSPF 1. To configure global timers, say timers throttle. What is the meaning by throttle in English? What? Accelerator. All those things which accelerate periodically, or you can say rapidly. Which can change rapidly. To control them actually. Like I have told you before that whenever there will be a change, whenever there will be any change in LSA, on a router, it will regenerate its LSA, and whenever a router will receive a most updated information, most updated LSA, it has to run SPF algorithm. Especially I told you these things in terms of router LSA. Fine. So whenever a router will receive any modified router LSA, it will run SPF. Wow, that's true, right? If changes are occurring frequently, it means your router will require to perform SPF algorithm, will require to execute SPF algorithm rapidly to control that, because if your device is executing SPF algorithm rapidly, you can easily understand that what can happen. I hope you people are getting my point. To solve that problem, you can control your SPF execution by using timers, by using global timers like timers total SPF. It is asking that delay between receiving a change to SPF calculation in millisecond. Like for an example, you received a change. So after like it has to schedule SPF algorithm now. Try to understand. It has to schedule SPF algorithm. It is not like that just after receiving a change it will immediately run SPF algorithm. No, it has to do wait for synchronization. It has to do wait for the completion of the synchronization, database synchronization. Like previously we saw that R10 formed neighborship with R11, but still it was not having routes available inside its own routing table because SPF was not executed immediately. It took some time. So basically this is the initial time. Like after receiving a change, let's say that you have received a change, so after how long you will execute your SPF algorithm. So let's say that you want to execute your SPF algorithm after 5 seconds or 2 seconds, tell me. So if you want to execute your SPF algorithm after 2 seconds, then you have to set your timer in 2000, because it will be in milliseconds, so you have to set it to 2000. Then minimum delay between first and second SPF calculation. See, the previous delay was for that, like try to understand, when we configure this 2000 millisecond, it was for those changes which are received very first time. Let's say I have received LSA, I have formed a neighborship very first time. And then after receiving LSS, after receiving database, I have to execute SPF algorithm. Route OSPF will require to execute SPF algorithm, but OSPF has to do wait at least for 2 seconds before executing SPF algorithm. But now let's say that again you have received another change. So again your device will require to run SPF to execute SPF algorithm. So what should be the minimum delay in between first and second SPF execution, SPF calculation? I hope that you people have understood. The minimum delay in between two SPF calculations. Let's say I wanna configure it 10 seconds, so 10,000, and then it will also ask you the maximum wait interval, the maximum time in between two different SPF execution. Let's say that you have received a change, you have received another change. So there will be now two things, minimum delay and the maximum delay. So this is maximum, minimum you have already configured. So maximum must not be lower than minimum. Maximum must not be lower than minimum. Yeah, minimum and maximum, both of them can be same. Both timers can be same, but if it will be depending on you. If they ask you that okay, maximum should be like 12 seconds, so you can configure it as 12,000 milliseconds. So this is the maximum time wait interval in between two SPF calculations. Previously we configured minimum, right? And this is maximum. So let's say that you have received another change. So you have to execute SPF algorithm in between 10 to 12 milliseconds. Sorry, 10 to 12 seconds. 10,000 to 12,000 milliseconds. So in between these two timers now, your router, your SPF will recalculate SPF, so test path first algorithm, you can say. Have you understood it or not?
Yes, sir.
So this is that how can we schedule SPF throttling, show IP OSPF. Check it out. Initial SPF schedule delay is what? 2 seconds. The minimum hold time between two consecutive SPFs is 10,000 milliseconds, and maximum wait time between two consecutive SPFs is 12,000 milliseconds. Fine. Okay.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.